with the slides, and we're gonna just jump right into it. And have you started recording? Okay, recording has started. Cool. I'm gonna just jump right into it. So today, I want to talk to you all about Declarative THREE.js in Angular. For those of you who don't know, THREE.js is a 3D library. The link for THREE.js is THREE.js.org. I mean, I say it's a 3D library, but it's actually an abstraction of a WebGL API. WebGL is a very low-level API that is available for you on the web, on the web API to allow you to draw 3D objects or 3D scenes on the canvas. THREE.js abstract all of that and give you a really nice APIs to work with, a little higher level to work with 3D objects. So I would highly recommend checking out THREE.js. All right, so before we start, my name is Chao Tran. I'm a senior engineer at Narwhal. I'm also a core team member at Nest.js. I mainly work with Swagger or OpenAPI module. So if you ask me about GraphQL or microservices, I don't know the answer. I might know something, but not very expert in that sense. But if you have OpenAPI question or Swagger module question from Nest.js, feel free to hit me up on Twitter. I forgot to put my Twitter handle here, but you can find me at NARTC. This is C-Tran backwards. So if you don't remember this, remember my name, Chao Tran, but then the C-Tran backwards. And then my 1410, this is my birthday. So you can follow me on Twitter and hit me up on Twitter. My DMs is open. So feel free to hit me up on Twitter. And I also am a brand new father. So this is my son, Brian. He's 6 months old. Right. So the agenda for today is, again, I'm going to go really briefly over what is THREE.js. Then I'm going to switch over to how do we write it declaratively in Angular. Then I will explain how does it work, how does the library work. And then I'm going to expand on the demo if we have time, and then Q&A. So again, what is THREE.js? Before we get into that, so this is a disclaimer. This is not a how to work with this library, this presentation is to show an introduction and what the library is leveraging from Angular to make everything work. So basically, I hope everyone learn about the Angular concept that I use to make the library happen. And again, the library I'm talking about today is a proof of concept. I hope to attract more contributors so that we can make that a solution for the Angular ecosystem to work with THREE.js. Right. Disregard this code. I forgot one slide in between, but THREE.js, as I said, is an abstraction over WebGL. And we're going to just go straight into the documentation of THREE.js. We're going to grab a piece of code. All right, we're going to grab this piece of code right here. And we're going to go open up Stacklist. You can, if you want to follow me, you can follow me on Stacklist. Just grab the Angular template, Stacklist, and we're going to start from here. So I just copy this code, and let me know if the font size is not big enough. So this is Stacklist. This is a brand new Stacklist Angular template. Before I start, I'm going to remove these two files, the Angular component CSS and Angular component HTML. So we're going to work with the inline template, so it's easier to see what's happening like that. I'm going to also remove the hello component from the template and clean this up a little bit and save that. Back to app component. All right, so before we start, we're going to have to install Three. This is the npm package of THREE.js, so it's just Three. And also, we need the type definition of THREE.js. So it's types 3. So we're going to install these two libraries right here, type 3 and 3. So while that's running, running mgcc. All right, so I'm going to say I'm going to refresh. The reason why I refresh right now because I want Specklist to be aware of the types 3 package so that I have IntelliSense. So S3 from 3. So you're just going to import 3. This is the convention when you work with THREE.js is to import star S3 all capital from 3. I'm going to remove this name and I'm going to put in ng undernet. I'm going to paste that code in, and you can just like immediately you see that it shows up on the screen, the spinning cube. What I want to do is I'm going to put in my canvas element because I want to manage this canvas element myself and give this a variable of canvas element. Just grab that canvas element, use a view child to get a hold of it. All right, it's going to be static 2. This is canvas element ref. It's going to be element ref of type HTML canvas element. So why do we want to have a canvas element when we work with THREE.js? If you don't provide a canvas element, THREE.js renderer will give you that DOM element, which is the canvas element, automatically. However, sometimes you want to manage the size or manage the wrapping container of this canvas, so you want to put it somewhere else on the page, and you have that ability if you manage your canvas element. So now that I have this canvas element ref, I'm going to put this right here, canvas, just start canvas element ref native element. And I'm going to remove this one. All right, save. So that's it. This is the basic of THREE.js. Just copy that code and put it in Angular. You can just use vanilla THREE.js with Angular out of the box, no problem at all. Right? But I'm gonna talk into why we need an abstraction or why we need a library to get rid of all this pain. Because right now you see that it works, but however, there's some like developer experience or user experience issue. Like if we resize the window, you see that the canvas size does not actually resize, right? And I don't know if you can see it, but it's actually a little bit pixelated on the object. You're going to have to take all of that into account when you work with THREE.js, vanilla THREE.js. Right? So basically, like for the resize stuff, you're going to have to add an event listener yourself to the resize event on the window, and you have to like do all of this code. So basically, it's going to be camera.aspect. Have to reset the aspect of the camera to basically this. Right? You have to reset that. You have to update the camera matrix. You have to update the matrix word, and you have to reset the size of the renderer. So if I save this now and I resize, you see that now it actually resizing. Right. All right. Just want to show how to work with vanilla THREE.js in Angular. And of course, down here you have the animation frame, request animation frame. So this method is going to run every frame. So it's going to run really fast. You see that my log, it runs really fast. It's run 60 frames per second, or that's the point that it runs at right now. So now in Angular, you know that it has the zone.js that's gonna check for change, and it's gonna trigger the change detection. So to be safe, right now we don't have any performance issue, but to be safe, more than often you're gonna have to inject the NZ zone ng zone and wrap everything in here. Wrap everything inside of here, inside of ng zone, run outside of Angular, so that you are safe. That is, this code, it runs outside of the Angular zone. So that is not trigger any chain detection, because at this point, all of the object inside of the canvas is managed by the canvas or THREE.js. So you don't really bind anything to these objects. So you don't need chain detection. Right. So I'll go back to the slides. Right. So this is really how the vanilla THREE.js code looks like. We have the scene and the camera. You're gonna have to have a scene, and you have to have a camera to look at the scene. Next, you're gonna have the renderer. So the renderer is gonna take in the scene and the camera to render the scene for you with the camera, looking at these, like the position on the scene. Next, you're gonna have some object. You have to have at least one object. In this case, our object is the spinning cube, right? We have the mesh. So mesh, think of mesh is like an object that takes up some space in the 3D space. It's just there. It's just some space. But then you're going to give it a geometry, which is the shape, and then the material, which is the texture of that. So think of the mesh is like it's just some space, and then the geometry is the skeleton, and the material is the skin. And then you're going to add the mesh to the scene. And finally, we're going to run that renderer.render, and we pass in the scene the camera, so that we render the scene on the canvas. All right, and then there's a request animation frame animate, so that if you want to animate your object, you can do this, because it's going to run over and over and over and over, 60 frames per second. All right, so that the THREE.js code looks like. And I want to stay focused on here. This is how you create an object in THREE.js. You can do this way. You can create a mesh first, and then you assign the geometry and the material later, or you can create the geometry first and the material first, and then you could use those and create a mesh. So just want to pay attention to this. It's going to be related to how the Angular library is leveraging this way to build your object. Right, so that's the vanilla THREE.js code looks like. And I'm just kidding, it wasn't right. I mean, without any framework, if you work with vanilla JavaScript, then again, that's all you have, right? And then how do we make it better for Angular developers? I mean, surely you can do better with Angular 3. So this is an inside joke. Angular 3 was never released. We have Angular 2, and then we have Angular 4. So this is an inside joke that this library is actually Angular 3, but it's actually not. It's Angular 3 with the whole word 3.js, stand for 3.js. All right, so that's an inside joke if you say Angular 3 with the number 3. All right, so before we go to the code, I'm gonna start to replicate this code with the Angular 3 project. And if you're interested, the Angular 3 library is available at the GitHub link at NARTC, again, C train backwards, narc, Angular 3. All right, the first thing that we're gonna do, I'm gonna refresh this kind of, right, the first thing we're gonna do, we're gonna install the library. So it's gonna be at Angular 3 /core. And Angular 3 actually depends on component store. So we're gonna install the component store as well. Yep, and I mean, imagine doing this locally while sharing screen, npm install and stuff. This is gonna be very, very, very slow. Running in GCC, when that's done, I'm gonna save, and I'm gonna refresh again, so that again, stack list with IntelliSense. Yep. All right. Save. Refresh. Right now we have Angular 3. What I want to do now is I really want to remove. Actually, not remove, but I'm going to comment out all of this, and I just bring this one out and comment it out and save. Then I'll go to my app module. So Angular 3 comes with a bunch of modules that you can use and import to build your 3D scene. The first thing is going to need is 3 core module. Next is 3 mesh module. So you remember that we need a mesh, right? There's a 3 mesh module that's going to give you that mesh element. Then you need the mesh basic material module. So again, remember, we need that mesh basic material. And again, we need the box geometry. So we're going to have that as well. So next is 3 box buffer geometry module. So all of these comes in its own module. So you don't, like, if you don't need anything, you don't need to import that module. That's kind of sense, like the scan pattern, single component as module. So that, and when we use Stackless, we have to import it manually, or you use VS Code, you have to import it manually. But if you use like WebStorm, and when you start typing the element on the template, it will suggest to import that module for you. So I mean, the developer experience is not that bad. All right, so now we have all of that import. So we have the components or the directives available to us. So first thing we're going to start with is the NGT, stand for Angular 3, canvas element or component. So canvas. All right, the NGT canvas, I'm going to explain in a little bit in depth later. The canvas actually gives you the scene, the camera, and the renderer. So we're going to need that, the NGT canvas, and then we need first we need the mesh, right? We need the mesh, NGT mesh, inside of the canvas. And we need O3D, which is stand for object 3D. So we annotate that this one, that the NGT mesh is an object 3D. Next, we need the geometry, so box geometry, NGT box geometry. All right. And we need the NGT mesh basic material, NGT mesh basic material. All right, and on the material, you can already see that we have that cube. I mean, that's kind of square on the screen, but it's a little bit small. I'm going to explain why. But before I do that, I'm going to grab the color from the mesh basic material example here. You see that when we instantiate the mesh basic material object, we pass it in like a parameters object. So the Angular 3 follows this convention from the vanilla THREE.js library, so that right, it is material is going to have a parameters input. It takes in an object. It takes in an object with the color, and you can give it that color. So now it's green. I'm going to save. Right now, why is it so small? It is small because the NGT canvas actually takes the size of the container. So right now, the container of this is this my app element. It does not like full size, full width, so that when you want to, you can wrap this NGT canvas in like a div, right? And like a div, and you give this div some size, so you can control the size of that, or you put in like a flex column. Okay, I want this to take up like half the screen. You can do that with flex or with grid. But now for this sample, I'm gonna just put go to style, just put HTML and body with the height of 100% and the width of 100%. Now we're gonna have this one. And as you can see now, if I like resize my windows, my aspect, like the object's still in the center, so my canvas is resized. So that event listener is built in out of the box for you. What's missing? We're missing the animation, so the spinning of the cube right here. So to animate something, so on an object, on the object 3D, which is this guy, it's gonna give you the animate ready output that you can use on cube animate. And you pass in the event.animate object. So this will give you, oops, I'm gonna go here, grab that, right? It's gonna give me the animate object. In this case, it's gonna be the cube, which is the three.mesh. Right? It is the mesh. And I can just copy what I have down here with the rotation. So up there, paste it here, uncomment, save. And now I have the spinning cube. And so I'm going to remove all of this code now. I'm going to close this. I'm going to remove this canvas. All right, now you can compare. Previous with the vanilla 3.js, everything is inside of your TypeScript file. Now you have everything is inside of your template, and declaratively you declare these, you write these template as you think about your 3D scene. And to animate something is just this simple. And the animate function is actually invoked outside of the Angular zone for you. So to double check that, we can always console log the nczone.ease. There's an ease outside, or is inside Angular zone. It's a static method, I think. This does not give me that, so I just console log that. Yeah, it does not give me that intelligence. So you can always check that it's actually running outside of the Angular zone. Right, so that's the main demo. I'm gonna go back here and expand on why this helpful. It's just gonna give you right here, this helpful because you see this mesh right here, and now you can just make this a component. Right? You can make a cube component, and then you can have multiple cube, right? You can have cube, and then each of these cube, because they are components, they can have their internal state. Which let me try to go through the slides and we go back and we expand on it. Any questions so far?
I think mine is more of a just being in awe because I was thinking like, okay, so are we gonna be writing all that vanilla JS code? But seeing this, yeah, makes things actually pretty simple. But yeah, I think taking us through the first part was really great because now we got to understand like how you can even do it just with simple vanilla JS.
Yeah, I mean, again, this is a wrapper. This Angular 3 is a wrapper. So to be efficient, you're gonna have to know THREE.js, right? So it's just a wrapper. It doesn't really help you learn THREE.js. But I mean,
okay.
if you want to use THREE.js in Angular with a more Angular way, then yes, go to Angular 3. And you can have this kind of syntax that you can work with. All right, we'll go back to my slides. All right, and here is the Angular 3 template that we just wrote. We have the NGT canvas, we have the mesh, and we have the box geometry and the material for this mesh. And this is the animate ready function or event that we handle, and then we're gonna rotate the cube on every frame. So that's the code of Angular 3 to give you that spinning cube. And of course, this is the import. 3 core is going to give you that NGT canvas. 3 mesh is going to give you that NGT mesh, and so on and so forth. Right now, I want you to focus on this piece. Because this is our 3D scene. What happened here? How does this work? All right. So I use content projection. You can see it's clearly right. we have the parent or the entity canvas, and then we have a component, and then we have something inside of the parent tag or the entity canvas tag. So immediately any Angular developer would know that, hey, this is content projection. You project something inside of that parent tag or component tag, right? And I use dependency injection, or more specifically, it's hierarchical dependency injection. However, it is not really content projection. I just use content querying. I'm going to explain. Right. So here I have parent child, very simple. And we all know that this child is the content, right, of the parent. And then inside of the parent component, we're going to have that ng content tag or directive to actually project the template of the child here, right? We can have like some header, some footer, but then whatever we pass inside of the parent tag is going to be projected here if we have the ng content here. And we can also query for the child component, the instance of this child component inside of the parent component with the content child. So this is basic concept. I mean, if you learn Angular, you're going to learn content projection and the querying with content child, view child. All right, that's all good. But then, yeah, I just highlight that you can do content projection or you can query for this child component. But did you know that even without the ng content, you can also query? This still works. This line still works just fine, even without the ng content. What does this mean is that you don't even have to project anything to query for it, right? At the time you write this on your template, and it goes through the Angular compiler. The compiler actually establish that relationship when at runtime you have that relationship already established for you in the dependency injection injector tree, so you can just query for it. You don't even have to have ng content here to establish that relationship, and that's a really, really key point to understand. Now I'll go back to our example with the NGT mesh, and mind you, the NGT mesh, it looks like a component, but it's not. It's just a directive. So it does not really have any template. So it does not have anything to project. But now if you look back at the stack list, I'm going to inspect this element. I'm going to inspect my DOM. If you look closely, I'm going to just increase the size of this. If you look at this, the entity canvas is the component because it has to have that canvas element. But then if you look, there's no way you can find the NGT mesh, NGT stuff like that, because this is not being projected on the DOM. So it's not going to pollute your DOM. You might have like hundreds or thousands of these objects in your 3D scene when you build like a very complex scene. And if I project everything, then your DOM is going to be really heavy. So I don't project anything. This is not project. It doesn't have a template. It's just directive with instruction for the library to work. So this is a point I want to point out, that it does not have any template. It's just directive. And of course, if you use the Angular Dev Tools, you're going to see all of these directives. Right? It is not hidden from you. It just does not have anything to display on the DOM. Right, now go back to the slide. So again, all of these are directives, so it does not have any template. Right, that's NGT mesh is the parent, and then all these two guys are the children. So in my mesh directive, I can query, right? I don't have any ng content here. I don't project anything. So I do have the query. So I query for these things, for these two, geometry and material. Right, that's box geometry and the basic material. And then I have my mesh, and it's in like for example, in ng-on-init, I'm going to instantiate my mesh. So remember, right, I have a mesh and I instantiated it. Remember when I said that you can have the geometry and the material, and then you pass these two inside mesh to create a mesh. So this is the syntax, because it could not work the other way. It does not work the other way. All right, so this is the content querying. So understanding this allow you to actually not rely on ng content or content projection to really understand that you can query for instances of components inside of your parent tag. So you can build more stuff like tabs component, table component, cells, and stuff like that can follow this pattern. All right, next is hierarchical dependency injection. So here is the canvas component. I have that entity canvas tag, and then inside of the component decorator and annotation, we have that providers array, which means that we can provide the injectables or services on this component. All right. But then if you remember this, the scene, camera, renderer, and stuff like that, the canvas component sets up the renderer, the camera, and the scene for you. And I want you to focus on this line, scene.addMesh. So with the content projection, content querying slides, we understand how a mesh is being created. Now, how does this mesh get added to the scene on the NGT canvas component? All right, so that's the structure of our template. Again, if you look at this, you can think that, oh, it's the same as content querying as before. So I can just query for the mesh directive inside canvas component, right? Like that. And then the canvas store that I provide here initializes the scene. So I can just do this .canvas store, the scene.add. I add the directive, the mesh to the scene, right? Yes, you can do that, but you can add literally any three objects to the scene, and sometimes some object can add other objects onto it. So if you look at the template here, you can see that I can put NGT anything, absolutely anything, in between the NGT canvas. But then in the canvas component, it poses the question, okay, now what else do we need to query for? Right? No one really knows. All right, now go back to this sample. Now we're going to look at the child component instead of the parent. Do you know that in the child component, when you have this structure on your template, in your child component, you can actually inject the parent component into this child component, right? Because it's the same tree, it's on the same tree, so you can actually inject the parent component to this child component, right? Like that. And then do you remember on the parent component, we might have some providers on the component? You can inject those too. So what does that mean? It means that I can inject the services that are provided on the parent component inside of the child component. So this is the link to the hierarchical dependency injection. It's actually on the official documentation. So give it a read. It will open up a lot of like possibilities for you to build your app, to build your component, to build your reusable components or libraries. Now go back to this NGT canvas, NGT mesh, like same structure, parent child. Now inside the mesh directive, we just learned that we can inject the canvas store in here. Canvas store was provided on the NGT canvas, right? And then we can just do canvas store .scene.add the mesh. So now we shift the responsibility of adding something onto the scene to that actual object, right? So, hey, object, when you instantiate, add yourself to the scene. Now with this is a little bit a simpler example, but I said that you can, that there are some objects that you can add other objects onto it, right? So this way, when I inside of this object, inside of this mesh, I can always check for my parent. If my parent is an object 3D, then add myself to that parent object. Or if my parent is a canvas component, then please add myself to the scene. So all of that logic, all of that checks happen inside of the object itself instead of the canvas component. Yeah, so again, just a gift for fun. All right, so understanding the dependency injection and the content querying allows me to build this library in a very declarative way, right? So that's all I want to show, right? We still have like 15 minutes or 20 minutes. I have time. I don't know if you guys have a hard stop or not, but I have time. Now we're gonna go back to the demo and we're gonna expand on it to see what we can do with this library. Before I start the demo, any question so far? Comments? Am I going too fast? I speak too hard to hear or whatever? Yeah.
I think you're pretty good. Yeah, I think it's a good speed. Yeah.
All right. Cool. All right.
Yeah, unless someone thinks otherwise.
Yeah. Okay. Yep. Of course. All right. So let's go back to this example and see what else we can do with it and what else the library provides. I know I said it is not a how-to, but I just really want to show you why do we want this. So as I said, now you can grab this one and make it a component. So that's what I'm going to do. I'm going to make export class cube component, right? And it's going to be a component with the selector of cube, and the template. Again, chain detection doesn't really matter here, but most people use on push. Right. So I'm going to copy this and I put this on the template. And I'm going to copy this and I put this in the component. Right. And instead of the mesh, I would say cube. And I can remove this one. Save. Right. Now we need to add declare this cube in the app module, which I need to refresh a little bit. Give me my app module declaration. Let's say cube component, save, back to our app component. Wait, what? Here we go. Right, so now we have kind of the same result as before, but now because now this is a component, we can have internal state. So what if we have a hover state, right? We have a hover state and we have active state. All right, so when are we hovering? So when we hover, when we have a pointer over, this is hover equal to, or when we have pointer out, this is hover false. With the hover, we can now change the color. Let's say we want to change when this is hover, we want to have the color of, I guess, orange. And if we are not hover, we have the color of pink or hot pink, more apparent. There we go. So save. Now if I hover my mouse over, now you can see that the cube changed color. Right, so now we have the internal state managing the 3D objects. This state is the angular state, but it's managing the 3D object, which is an object on the canvas. And one more thing I want to point out you see that this entity measure directive has some of these output or event emitter, but we also learned that these don't really have anything on the DOM. So where does the event come from? So the NGT canvas, this guy set up an event listeners within the canvas itself using raycaster. So when you work with 3D object, your mouse act as like a ray of light that's gonna hit this object. Like say the light say, hey, I hit this object at this point, and it's gonna emit some events. The NGT canvas abstract all of that for you and give you a very angular API to work with when you have event on your object. Next, with the active state, so we have a click, and active will be toggling the active state. And what do we do with the active state? So on the mesh, there's a scale. We say if you active, then I want you to be a little bit bigger. So 1.5, 1.5, 1.5. So like 50% bigger. And then if you're not active, then keep your whole O size. So now if I hover, I click, now you see the cube's bigger. And so that, again, internal state. Now your component also can take in what input. Right? I can take in position, and this position is a 3, vector 3. So it's gonna be like X, Y, and Z position in 3D. So with position, I can pass in my position to my mesh position, and default is going to be 0, 0, 0. So it's at the center. Now I want to position my first cube a little bit to the right. So my x-axis to point to the right. So as you can see, it's a little bit on the right here. And I want to have another cube with a little bit on the left. So now these two cubes have their own state. And if you remember the vanilla THREE.js code, there's a const cube. I mean, if you want to have it in a cube, you're going to have to duplicate that code to have this old state. Right? And I can play with it. I can have a little bit more, even more stuff in here. So now I want you to be up a little bit. This guy, I want you to go down a little bit. You have 4 cubes. And if you remember, I said there's some objects that you can add other objects onto it. So you can have a group, and to work with a group, we're going to do 3 group module. And here we can do NGT group, right? NGT group is also an object 3D. Paste all of these in, and now I can do animate ready on the group. Animate ready on the group. I say on group animate. Again, event.animate object. Copy that. Down here, you see the group, and it's a 3.group. And we'll just do group.rotation.x plus equal 0, 1. Oh, rotation, like that. Rotation. And now I rotate a group, but this group has all of these 4 objects inside of it. So the whole 4 objects spin. Right. So, and then again, all of these cubes still have their own state. Right. So, I mean, of course, there's more. There's light. I want to show something else as well. Let me refresh so I can have that. There's an Angular 3 package with the controls library. So this controls library will give you some camera controls directive. So now that is installing. Installing. This is going to be 3 object control module is going to be from 3 object controls module from another 3 controls object controls. I think. Save. Still work? Yep. All right. So now with that, I can just put NGT object controls, NGT object controls, save, and now I can use my mouse and move my objects. I'll move my camera around. I can zoom, I can pan, and of course I can rotate. All right, so I mean that's it for the demo. We're running out of time. So I'm gonna leave some time for Q&A. All right. Any questions?
Sorry, can you hear me?
Yeah.
Yeah, and yeah, and I have one question about the performance of this library. Do you
Okay.
have, yeah, can you give any more detail in the performance of this library?
Performance-wise, it's not really bad. I'm gonna show you something here. I'm gonna let's see that. Let's see if I can run that. So if we go to LS, I have Angular 3 here. Let's see if I can run this. So this is my local clone of the repo of the library, and I do set up some demo. And I'm gonna run the serve demo here. We don't have to install anything because it's already installed, so it should be good to show. When we talk about 3D or 3D scene, what we worry about performance-wise is the frame rate. We always want to make sure that the consumers or the users of our website or web application experience 60 frames per second, or at whatever rate their monitor allows their run at. So 60 frames per second is a smooth transition or animations to humans' eyes. So you want to maintain that. So here you run, I don't know if you can see it, I don't know how to make this a little bit bigger. Yeah, right here. So you can see that's right here. It's running at 53 frames per second because I'm sharing screen. But if you run this on your machine with this simple animation, with this simple scene, with 2 spinning cubes, you're gonna see 60 frames per second. Like this one right here. Again, I'm sharing screen, so it's limit my frame rate at 53, but it should be 60 frames per second when you run on your local. So you see how many objects we have here, and also here, a bunch of objects. Like each of these birds is an object, and it runs just fine on my local machine. It probably is a little bit laggy in share screen, but it runs just fine here. LOD, I have, I think, like 5,000 or 1,000 objects here. And these objects actually change the level of details as they move closer to them or like further from them. And the performance is just fine, very smooth. Same thing here. I think I have like 1,000 cubes here. And the performance is really based on how you build your scene with THREE.js rather than Angular is going to make it slower. It's just the wrapper around THREE.js. So if you build THREE.js slow, then you're gonna build Angular 3 slow, because there's a whole bunch of topic around optimizing THREE.js. I hope that answered your question. So
yeah. Thank you. Yeah, and can you share your remote?
Absolutely. Yeah, I will share. I will share everything. I will give Wayne, Yakuo, all of my links from this talk, the slide, repo, the demo, all of that.
Yeah.
Share that with him. And when he uploads the recording, he's gonna put it in the description.
Yes. Yes.
Thanks.
All right, I'm gonna stop sharing. And
If anyone, please feel free to ask a question if you have a question.
yeah, I mean, feel free to. And by the way, I'm looking for contributors. I cannot do this alone. There's a lot of like documentation still having to work through, and of course, it is in beta. There's a reason it's still in beta because I'm not very confident to release this officially.
Okay. So is it like the project that you just showed us?
Yeah, the Angular 3 project is in beta right now. I mean, it should work just fine, but I don't really have a use case to actually showcase it.
Yeah.
I mean, if you're on Twitter, if you follow like Svelte, then you know that the Svelte author, he works for the New York Times, and they keeping track of the Olympics. So they built a very cool visualization of the Olympics track team, like they run and the hurdles and stuff like that. So they use THREE.js. So they actually have a use case to build that with Svelte. I'm gonna share with you Galkio and everyone the link to the tweet.
Okay.
And he ended up building a Svelte 3 library. So just like what we have here with Angular 3. So with his tweet, first I think that it's really cool that he does that. Second, I think now that the importance of having like an abstraction over something like THREE.js, because vanilla THREE.js is not easy to work with.
Anyone else who has a question? Please feel free to ask.
Yeah, you can absolutely ask me anything. Angular.
Yeah.
Doesn't really have to be about 3. Yeah, while we have time.
Yeah. Probably I think this is for like entry developers or just people who have been in the game for not so long. But so probably it's more of like so what are the like benefits of having such kind of skills whereby you can like create 3D scenes within your web apps, like what could be the benefits of that?
Of course, your website is gonna look so much cooler. That's the I mean the wow effect, and it's really depends on the use case or the nature of the projects. If you're building like games and stuff like that, you might want to have some. Or you work for like Nike, or you work for like Adidas, or if you have some like 3D skills, then you can build a hella good landing website for like the new product, like where you can show like the new shoes, 3D's new like 3D object models of that shoes with like color changing and stuff like that. Like if you think about it, like the product side, like Nike and Adidas, they've been having 3D capabilities on their site for new products for a long time. Or cars. If you go to any car website, like they have that like 3D models that you can play with, right? And now getting to like real estate, like people have like virtual like house tool where you can have like 3D scene in the camera and walk people through like all the pictures of the object 3D models of the house. Like there are use cases for it, but I mean, it's not essential to know 3D or to learn 3D, but it's fun. It could be rewarding depending on what you want to do. It's not like you have to know 3D, like you have to know state management.
Okay.
But it is an extra skill, additional skill that if you have time and effort for, I think it's really rewarding. It gives everyone that wow effect.
Very true. And this is probably also to what's one of the question that Tran asked. So does the internet also kind of affect the frame rate, for example?
No, the internet will not affect the frame rate. As soon as the user load your 3D site, they and you know this is JavaScript, right? We're not loading additional thing or except for you playing the games or you scrolling and stuff like that. They have a lazy loading, so that's going to affect a little bit. However, as soon as you have all the assets downloaded, then it really depends on the consumer's monitor. The consumer's monitor might be limited at like 40 frames per second or 30 frames per second. I guess most monitors now is 60 frames per second. Some gaming monitor might go up to 100, 144. So now that's where you're going to have to worry about the frame rate, because this is going to like gaming a little bit. Higher is not always better, because if you build a game and you do not limit the frame rate, now the person with a better monitor, with better money to buy a better monitor, might have a better advantage than the person that does not have that luxury, because now things going to be a little bit faster on their screen, because now it's going to run at 100 frames per second. So they have more time to react to things rather than the person with 60 frames per second. Okay. So it's really depends on what you build, but performance-wise, it really depends on how you build your 3D scene rather than the consumers being the bottleneck.
Okay. I think that's it for me. Anyone else who has a question? Or a comment or just anything?
Yeah. How was it? I mean, like, how was it? How actually, did you guys learn something like today? I mean, I hope you do.
Yeah, this session is so wonderful. We learned a lot. I personally learned a lot. And I will display more 3D scenes in my carving Angular applications. Yeah, thank you for that.
Thank you.
Tran, you had something to say?
Actually, I see this project is really interesting, and I'm sure I don't have solid skill to dive into deeper into the Angular application. I mean I don't trust myself in in the professional way in the Angular to build the library.
Oh, yeah. I got what you mean. I understand what you mean. Yeah. So I mean, that's kind of why I put this talk together, to really show that you can actually leverage very basic concept of Angular to build a library. I've started building libraries for Angular for a couple of years, and to be quite honest, it's different than application developers. I mean, library developers think differently, because now we have to worry about like customization. We have to worry about like different use cases and stuff like that. Right? So now having the understanding, having the knowledge of, oh, now I can actually have like an abstract class, provide this in the dependency injection, then the consumer can customize it and stuff like that. So really understanding the basic concept, which I'm trying to convey here with this talk, is to help more people to be more confident in building reusable libraries. And of course, it's going to start within your application first. let's say, oh, we have this use case that we can reuse, and then in your application you build that, and then you say, oh, now I have another project that I'm gonna have to use that component. Now you're gonna have to think about publishing it. But then open sourcing it and stuff like that is a different story. But if you have the knowledge, you build a good reusable library that you can use for your multiple projects within your company, then I think it is a good candidate to open source. And you are good enough to build a library for people to use. Don't feel that you're not good enough.
Yeah.
I bet people here build reusable components.
Yes. Yeah.
Yeah, because I think that's actually true, right? You know, like you always have to get started somewhere. So don't think of yourself like you can't be able to do it. You know, it starts with that just simple line of code, you know. Because also I think we also had a session on how to build like NPM packages for Angular, and we have that video on our YouTube channel. So yeah, just feel free to go there and like just check it out. Personally, I had never even thought of how to write a package, but after the session, I was able to actually do it and then publish it on NPM. So, you know, you could just, it doesn't have to be something like really big. It could be even simple as probably like a calculator.
Yep.
Something
Yep.
that's even your friends
Absolutely.
use
Yep.
them
Absolutely.
in the Angular
Absolutely.
projects. Yeah.
Yeah. You have a mindset of like to start doing something, and then you good to go.
And yeah, we are always here to support. So you know, just reach out to us, reach out to Chow if you want. Just, you know, like have a chat with him. You know, definitely help out.
Yeah, I mean, feel free. I mean, if you have time, reach out to me with your questions. If I cannot answer it, then I'm willing to brainstorm with you. If you're willing to, just jump in a Zoom call and we can chat. You know.
Yeah, it's okay. Yeah. So
Yeah. This is another comment from one of the attendees. He said like the session was quite mind blowing, and they really loved the session. And yeah, they said thank you to you, Chow. So yeah.
Thank you. I mean, I love. I love to share this. I love to see you guys learn something from my talk. This is kind of my problem. I don't know. I feel like I have to have something to teach people before I put together a talk.
Yeah. Well,
it's
I think that's the whole idea, right?
Yeah, but like you know what I mean. Like I feel like everything that I know, people know. So when I look at other people, like talking about do this in Angular, do this in NGRX, do this with NX and stuff like that. I thought people know that. So that's why I never actually worked on those topics. So it's a strain on my end. It's a constraint on myself. So like, hearing people learn something from my talk is really encouraging. So thank you.
Yeah, because I'm pretty sure that you know, like for some of the communities, like for example, our community, we've never had a session like when I'm talking about like 3D scenes and all that. Yeah, we've seen websites like how they do it, but hearing from you and like just explaining like what happens behind the scene is pretty amazing. Yeah, thank you for that. Yeah, and if there's no question, if there's no other comment, I'd like to pass this over to Sandra to close the session for us.
Hello. So the session has come to an end. We'd like to thank you, Chow, for the wonderful session that you've had about creating 3D scenes. And we're hoping to see you again to take us through another thing at another time. Thank you so much for your time. We appreciate it. Yeah.
Yeah, and so the recording is going to be available to everyone who's going to be interested in watching it. by tomorrow afternoon. So feel free to just check out our YouTube channel. Just search for Angular Kenya. You're going to see us. We have tons of content over there. Yeah, as I mentioned, Tran, if you are interested in learning about how to build NPM packages, we have a video for that. It's pretty, like for beginners. So feel free to just check it out, and other content that you may be interested in. Yeah. Thank you for everyone for coming, and yeah, see you in the next session. And thank you, Chow. Thank you very much.
Thank you. Thanks for having me. All right. Bye, guys. Love you guys. Hope to see you again soon. All right.
Yeah.
All right. Bye.
Yeah. Bye.
Bye.